This round lid could crush a sedan, but it won't fall in. That's not tradition, that's geometry, square ones, criminal negligence. Let's talk about why the circle is the only civil engineer who actually read the textbook. A circle has a constant width. Rotate it. It fits the exact same hole. A square. Rotate it 45 degrees and boom. Instant drop. We're talking about a 300-pound cast iron disc falling into a sewage trench. Physics doesn't care about your aesthetic. Okay, it won't fall. But how does it handle the weight of a city bus? Load distribution. A circle funnels vertical stress evenly along the rim. Think of it like a pressure cooker for gravity. Square corners, stress concentrates. You get microfractures. Eventually, the lid cracks, buckles, and sends a delivery truck into a municipal time machine. Cracked edges are just the beginning. What about daily abuse? Water drainage. Circles seat themselves. The rim creates a natural water channel that prevents the lid from floating during flash floods. Squares trap debris. They jam, they tilt. They become tripping hazards disguised as urban art. But what about manufacturing? Why not just stamp out squares cheaper, machining tolerances? You can drill a circle on a lathe without repositioning the workpiece. A square requires indexing. More steps, more errors, more budget bleeding. The round cover is a lean manufacturing masterpiece disguised as city furniture. So squares are inefficient. But what about the actual failure modes we see in the wild? I see the comments already. What about square utility boxes? Fine, those aren't covers. They're access panels bolted to frames. If you put a loose square lid on a street, you're not innovating. You're running a structural skill issue. The math literally fights you. But if circles are so perfect, why do we still see cracked ones? Thermal expansion. Every city sweats. The iron heats up in July, contracts in January. Circles expand uniformly. No warped edges, no binding, square covers twist. They seize. They demand a forklift and a prayer to get them back out. So it's math, manufacturing, and maintenance. But what's the real historical reason we're stuck with it? 1900. Urban plumbing scaled up. Engineers needed a fail-safe that required zero training to install. The circle won. Not because of nostalgia, because it survives. Every square alternative since has been a cautionary tale in civil engineering textbooks. But let's be real. Could a mathematically perfect shape ever be flawed? Only one. Theoretically, if the hole is slightly tapered, a circle could wedge. But municipalities angle the rim outward. We literally engineered the loophole. Squares, they just fall. It's that simple. So it's geometry, stress, and history. But what about the next generation of infrastructure? Smart grids. Sensor integration, composite materials. The shape doesn't change. The circle adapts. It's the only geometry that respects gravity, stress, and basic common sense. Square lids, keep them in the comments. Hexagons, triangles, developers want them. Architects design them. They're trying to make the street look like a graphic design portfolio. Meanwhile, the load-bearing capacity drops to zero. You're trading structural integrity for Instagrammable concrete. Bad take. Subscribe for more engineering vindication.